Today we are going to start the chapter light. Here we will discuss about the simple application of refraction of light. That is, here we will discuss about the real depth and apparent depth. So real depth means that is actual depth of an object. It is if it is placed in a second medium and we are observing it from a different medium. So suppose this is the separating medium. This is the separating medium, that is separating surface which is separating two medium, that is medium 1 which can be taken as air and medium 2 can be taken as water or glass. So the object is in second medium. So suppose that object is here, we can take it as O and the surface separating surface is taken as S prime. So the object is at O and we are looking it at from air. Okay, so as we are looking it from air, the light ray must enter my eye. So I am drawing this eye little here. Okay, so the light ray from O will enter my eye so that I can see the object. So here I will draw a ray of light which is entering my eye. So the light ray is coming in this position, in this position. So as we know that the water is a denser medium, right? And if this is the normal drawn to the surface, so when a ray of light is going from a denser medium to rarer medium, it will go away from the normal. So here we can see that light is going away from the normal drawn. So this is the incident ray and this is the refracted ray. So that was I is an incident angle and R is the refracted angle. So if we can say that another ray if we draw for the normal incidence, so this will be like this. This is for the normal incidence. So ray of light will go like this and will come back here also. Now, as we can see that in this case, my eye cannot follow this bended path, right? Because my eye cannot see this bended part. It will always see the straight line. So my eye will follow this line. Right? I will draw straight from this. This line should be straight. Okay. So as I can see this straight line my eye can follow. That is so here we can see that is the real depth of the object. That should be this. This position should be the real depth, right? This is the real depth. But my eye is following this straight line path, and so that the object will appears to be in this position, that is here. So the image of an object or the object appears to be in this position. So the length or the depth from this surface, that is this distance, should be apparent depth of the object. So the real depth and apparent depth we can write like this. This is the real depth and this is the apparent depth. This position and this is the real one. So as my eye can follow only the straight line path, so the object appears to be a little shifted from his original position. So this happens due to the diffraction of light, and as we already told you that this is due to the refraction of light because because of the change of the medium, it also causes the change in refractive index, and that also causes the change in velocity, and that's why the ray of light changes direction. Now we want to find the relation between the apparent depth and the real depth here. So here we take a surface SS prime which is separating two medium, that is air and water or glass. The light ray is coming from an object O, so OB is the incident ray, and the light ray is refracted, so BC is the refracted ray, and this is the incident angle I, this is the angle of refraction R. Now here we are going to discuss about the relation between the real depth and the apparent depth. As we can see that OB is the incident ray here and BC is the refracted ray. So angle I, that is the I is the angle of incidence, that we can write as I is the angle of incidence, that we can write as angle OBN prime or N dash, that is the angle of incident, and angle of refraction, that is R, which can be written as R is CBN or NBC, what we can write both. We can write it as this, and we can see that here BN prime, that is this line BN prime, and AO, this line, are parallel to each other. So if we take this position, only this position, this will be like this, B N prime O and A, and this is the transverse line. So we know if this is just like the Z angle, right, alternate angle, so those are equal, we know that. So as OA is parallel to BN prime and OB is transversal line, so we can say that this two angle OAB, or sorry, I need to pull, this will be A, this will be A, and this will be O, right? So angle AOB will be equal to angle OBN prime. So angle OBN prime is angle I. So angle AOB is also I. So this angle is also I, right? Now, similarly for the second case also, so to prove that the angle of refraction is equal, so we are taking that I is this I, and A. So IA, this line, we can write it as A prime also. So here we can say that IA prime and this line, those are parallel. Okay, so IA prime and BN are parallel. Here we will write it and shortly. So we will write it IA prime parallel BN, and here we can see that this line, that is IC, is the transverse line, is the transversal line. So as for this reason also we can say that angle CBN, that should be equal to BIA prime, that is this line, BI and A prime. So as CBN is R, BIA prime, that should be also R, means this angle. Okay. Now we will take the triangle BO, we will take this triangle, that is BOA. So taking the triangle BOA, BOA means this triangle, this small triangle I am taking, okay. From this triangle, this is a right angle triangle, as we can see this angle is a right angle, so angle BO is a right angled triangle, okay. So for this reason, as this is a right angle triangle, so what we can write sine I from this. Sine I, we know what is the meaning of sine I. Sine I means that is the perpendicular by hypotenuse, right? So here the perpendicular as AO means this angle is a 90 degree. So the sine I will be equal to, this will be the perpendicular, that is BA will be the perpendicular, and the hypotenuse will be OB or BO. We can write anything. So as sine I is equal to this and sine R. So to take sine R, we must not take this triangle. We will take this small triangle. Okay, this small one. So for taking the triangle BOA, I am taking sine I from this triangle, and we will calculate sine R with this triangle, this small triangle, that is BIA. So the first thing we are taking out from this, that is sine I is equal to BA by OB, right? Now from triangle BIA, which is also right angle triangle, is also a right angle triangle. So triangle BIA is we are going to take. So BIA. This is also a right angled triangle, right? So here we can say that sine R, that will be also, that is the perpendicular by hypotenuse. So here also perpendicular is AB, by hypotenuse is so hypotenuse is this one, because we are taking the small triangle, so this will be IB or BI, both we can write. So what will be the refractive index in this case? So the refractive index from A to B, so where we are taking the first medium as A and the second medium as B. Okay, so from A to B we can write that is sine I by sine R. So the refractive index of the second medium with respect to the first media, that we can write, that is this sine I by sine R. Now as here the light ray is going from water or glass to air, so here we will write it as the refractive index of air with respect to the second medium, this medium. So here the water and glass is the first media, because the light ray is going from this medium. So here we can write M, or we can write water or glass, whatever the second medium is. So this will be M mu A, that is the refractive index of air with respect to the first media. That will be sine I by sine R. Now sine I, that was equal to AB by OB, and sine R is equal to AB by BI. So we can write it as BI by AB, right? So this will get cancelled out. So we get BI by OB, right? So what is this BI and OB? Now as here we will take an approximation, that we will take that the point B and A are very close to each other. So taking B and A are very close to each other. So the distance BI, that is this distance, will be almost equal to BI will almost equal to AI, and OB will almost equal to OA. Okay, these two are assumption taken by us. So as this is the case, so mu MA. So here BI by OB, that was the case. So we can write it what here now as taking this approximation AI by OA. Now AI, that is this distance, that is the apparent distance, and OA, that was the real distance. So we can write it as apparent depth by real depth, right? Now this was refractive index of air with respect to the medium. So we want to take refractive index of that medium with respect to A, because here we want to find the refractive index of the second medium, because we don't know what is the second medium is, what the second medium is. So here we will just take the reciprocal of this, that will be the real depth by apparent depth. This is the relation between the real depth and apparent depth with the refractive index. So from this relation we can also find the depth of apparent, we can also find the apparent depth by just taking, by putting this value we can take out the apparent depth, or we can putting the value of apparent depth we can find out the real depth, or if we know the both depth we can find the refractive index from this relationship. So here we want to take out what is the shift, that is, we know this is the real depth and this is the apparent depth. Now there is a shift of depth, right? So this shift, that is OI. So what is this? What is the value of this, or what will be the formula of this? We will now calculate that. As we can write here, that is the shift, that is equal to shift is equal to OI, that is the distance, OI is the shift, right? So shift can be written as the real depth minus the apparent one, means this, right? Now as we know, the real depth minus, we are substituting this apparent depth by real depth by mu, where mu is the refractive index of the second medium with respect to air or the first medium. Okay, we are just writing it as mu, or we can write it as mu m for your knowledge. So we are taking out this real depth, taking common real depth, that will be 1 by 1 minus mu m, right? So this is the shift or OI, that is we can find out the shift or OI, that is the displacement of these 2 points using this formula. Now from this relation we can see that the shift depends upon the refractive index of that medium. Now we have already done that the refractive index of violet light is more than the red light, because the wavelength of red light is more than violet. As the wavelength of red light is more than violet, that's why the refractive index of violet light is more than red. So from this relation, as the violet light refractive index is more than the red one, so the shift is more for violet light. So the violet light, if we use a violet light and a red light, so we will see that the violet light shows more shift than red light. Okay. Now there is also some practical applications of this, or examples of this we can say. So taking one such example, where we can see that if this is the surface of the water, we are taking it as water, and the stick is in this position. So if I am looking it as an observer from this position, okay, so I am looking at this stick from this position. Now the same thing happens for in this case also. So I want to look at this point, that is the end point of that stick. So the ray of light will come from this line, and this is the normal, and will go away like this. Another ray of light is coming from this direction. Here this is the normal to this surface, and will go like this. Now my eye cannot follow this bent path, so I will follow this one and this one. So I will see that the object is little shifted. So for me, the object will be, that is, this stick will be like this. So this is the actual stick that should be like this, but this ray of light is coming from my eye, meeting at this point. So I will see this stick in this position. So I will not see this, I can see only this. I am drawing it, I'm just want to draw it more clearly. So this stick will appears to be in this position where these two lights meet. These two lights meet. So the stick appears to be in this position, which is the apparent depth of that stick. So this is the cause. The reason is same, because of the refraction of light. So my eye cannot follow the bended path, so I will follow the straight line and I will see that the stick is in less depth. Okay, so these are the consequences of refraction of light. The same thing happens for if we are talking about star. We know the stars are twinkling, so star always looks like that, and we know the twinkle twinkle little star. So this is the cause, because here we cannot just give the reason of twinkling of star, that apparent depth and virtual depth. With the help of this, we can give the give the reason of twinkling of star with the help of that the change of refractive index of medium. So as a light ray are coming from a very distant place, so that there is always a change in refractive index of the medium, so that the light ray changes its position, changes direction. So when it comes to my eyes, I will see that I cannot see the different bended path of light. So I will follow the straight line, and so that I will see the stars twinkling. We can give example of this thing when a man is standing inside a tank. So if he looks down, he will see that its leg appears to be short than the actual length of its leg. So these are the causes that can be defined, that can be justified using this phenomena, that is the diffraction of light. So here we are going to take an example. The question is, a fish is looking at a 1 meter high plant at the edge of the edge of a pond. What will be the plant appear shorter or taller than its actual height? So here we take a tree AB. So AB is the tree. Okay. Now the fish is in position O. So the fish will see from this position O to that tree AB. Now if the ray of light emerge like this and it reaches the surface, so here we draw the normal n prime. So that is the normal, and we take this place as Q. Now OQ is the incident ray. Now as the ray of light is going from water to air, that is the denser medium to rarer medium, so the ray of light will bend, right? Ray of light will change its direction. So suppose the ray of light goes like this. Okay, so it meet at a point here. So suppose this point is S. Okay, suppose this point is S. But the fish cannot follow this bended path. So the fish will follow the straight line. So the tree will appears to be little taller. So it will meet at a point P. So as we can see, the fish cannot follow the bended path. So we are joining the straight line Q with P. So the ray of light will meet at the point P and fish will follow this path. So the actual height of the tree was AB. Now the apparent height is AP. So the tree will appears to be taller than its actual height. So here we take a sum. A coin placed at the bottom of a beaker containing water, refractive index 4/3 to a depth of 12 centimeter. By what height the coin appears to be raised when seen from a vertically above. So we are going to see the object from vertically above. So here we want to calculate by what height the coin appears to be raised. So we have to find the apparent depth first here. The thing is given, a coin is placed at the bottom of the beaker of refractive index. So the refractive index of water is given as 4/3. So this is the refractive index which is given, and the second thing is given, that is the real depth of the beaker. So the real depth, that is R, we can say at real depth as LR. LR is the real depth, which is equal to 12 centimeter. So the LA, that is the apparent depth, is equal to real depth by mu, right? So the 12 by 4/3, so 3 will be get multiplied. So this will be 9 centimeter. So the apparent length or apparent depth of the object, we can write it here. Okay, hope you can see now. So the apparent depth of the object, that is 9 centimeter. So here we want to find the appears to be raised, that here we want to find the actually we want to find the shift, that is how much it shifted from its actual position. So the shift, that is OI. What we know the formula of shift, we know that is the real depth minus apparent depth. So real depth is 12 centimeter minus apparent depth is 9 centimeter. So the 12 minus 9 is 3 centimeter. So my answer will be 3 centimeter here. So you have to be careful in this sum, because here we want to ask the to be raised. So here we are not actually want the apparent length, we want the shift here. So you have to be careful about that.